talk about springs. It is used in many things. It is used in children toys. It is used in buttons, watches. From these small things to automotives, these are used in cars, in the suspension of the automobile. These are used in airplanes. In any complex machine, spring is an indispensable part. Why we use spring? What is the purpose that they used in so many places? It is because they exhibit one fundamental property of mechanical system or a or matter in general, that is elasticity. So any material in existence has flexibility or a kind of elastic nature associated with them. For example, what is elasticity? Elasticity is regaining their original shape after being stretched with an outside load. As soon as the load is removed, the matter start regaining its original shape. That is elasticity. Spring is designed to make use of that property in mechanical system. It create an artificial type of elasticity. You can make a spring depending on your elastic requirement in the system. So the elasticity is represented by what? Spring constant, which is equal to force applied on the spring. The elasticity or the spring rate or spring constant of the spring is force needed to stretch the spring uh, by a unit amount. If your unit is millimeter, it is the force required to deform the spring or stretch the spring or compress the spring by 1 millimeter. If you are measuring in meter, it is the force required to stretch the spring or compress it by 1 meter. Obviously, K in millimeter will be much smaller or 1,000 times smaller than K in meter because meter is 1,000 times bigger unit than millimeter. So whatever force you may need to stretch a spring by 1 millimeter, you need 1,000 times more of that force to, to stretch the same spring by 1,000 millimeter or 1 meter. So that is all about spring. Now, what about energy? Because when you stretch the spring, it kind of pull back on that, on your load, on your effort. So that is because your pulling of the spring store energy in it because of its elastic property, and that energy is represented by spring rate times square of the deformation that is caused by the load that you have applied. It's equal to F. So in simple mathematical term, F is equal to kx squared. That is its formula. The more you pull it, the more energy you will store, and even the energy, the relationship between force and energy here is is x square. So I think it's parabolic. So the energy will increase. The energy is proportional to the square of the distance the spring has been stretched. So that is it for today, guys. Thanks for watching.